In this video, you will learn about different types of compounds, mainly ionic versus molecular, and then we'll talk about acids and bases in a later video. One way to differentiate between ionic versus molecular is whether or not they can conduct electricity. So strong electrolytes will conduct electricity very strongly. So you will see that the light bulb goes on. And if it's a strong electrolyte, that means that there are ions in solution. So remember, ions are charged particles, and they're able to carry that electric current through the solution. So ionic compounds have ions. So something like sodium chloride, right, is an ionic compound, and it will produce ions when dissolved in water. So if you put this in water, right, you will get sodium and chloride ions, and that can conduct electricity. Some compounds, though, are weak electrolytes, meaning they only weakly conduct electricity. And that means you're not getting a lot of ions in solution. So this is hydrofluoric acid. Okay? And we'll draw this double arrow, meaning that it can go in both directions to get the hydrogen ion and the fluoride ion. But most of the time, we have HF in solution and very little of this. So this reversible arrow means it can go in either direction, but for this case, being weak, it is favoring being together. This is associated versus dissociated. So we have more HF around, so very little of this. So if you're a weak electrolyte, you have few ions around. And then a non-electrolyte is something that does not conduct electricity. So if you put it in water, like sugar, it will dissolve, but it cannot conduct electricity because the sugar molecule is not an ion, right? It's a molecular compound. So in this case, this one is molecular. This one is molecular, right? And this one is ionic. And you can have some, like this weak acid, in between. Okay, so ionic and molecular compounds. How do they differ from one another? Okay, so just to review our periodic table, remember these elements on your left-hand side are your metals, and in this upper right-hand corner are the non-metals, including hydrogen. Okay, so for ionic compounds, you're going to see that it is composed of ions, so one metal, that is the cation, and one non-metal, which is the anion. Okay, so for example, right, sodium is your metal cation, and chloride is your non-metal anion. They have attractions called ionic bonds, okay, between the positive and the negatively charged ions. So it is an electrostatic attraction between the opposite charges, and this is a very, very strong attraction. Therefore, we will see high melting points and high boiling points, meaning it takes a lot of energy to separate them. They are hard crystalline solids at room temperature. So just like you know about sodium chloride, right? It is a white crystalline solid. They have high densities, meaning the atoms are tightly packed, right? And once an ionic solid is dissolved in water, right, or melted, right, we can see that the ions are moving freely and they will conduct electricity. They will be electrolytes, strong electrolytes, in fact. Right? Molecular compounds. These are composed of 2 or more nonmetals. So they have to be combinations, right, of elements on the upper right-hand corner or with hydrogen. Okay. So an example here, right, what we're looking at there is carbon dioxide. Right? Carbon's a nonmetal, oxygen's a nonmetal. They are held together by covalent bonds. We will learn about these in a later chapter in more detail. They have relatively low, right, melting and boiling points. They are, if they're solids, they're often soft, or they can be liquids or gases also, right, at room temperature. They have low densities. They have low solubility in water, and they are weak or non-electrolytes. They are also poor conductors of electricity. And so here's a picture of carbon dioxide, which is dry ice. Okay, so solid carbon dioxide is dry ice. And we know that that solid, right, is pretty soft. Right? And it has a very low boiling point. It goes directly from, doesn't even melt, goes straight to the gas phase. Remember, this one sublimes, right, to carbon dioxide gas at, at a very low temperature. All right, so let's do some practice. Identify each compound as ionic or molecular. Okay, so pause the video, try and answer these, and then resume the video. All right, so let's go over the first one here. We have carbon and chlorine. You look at your periodic table, they're both nonmetals. So this is molecular. That's a molecular compound. Calcium with fluorine, right? Calcium fluoride. This is a metal, this is a nonmetal. So that one is going to be ionic. Sulfur with fluorine, right? 2 nonmetals. It's molecular. H2O, that's water, right? Hydrogen's a nonmetal, oxygen's a nonmetal. So that's a molecular compound. And sulfur dioxide, and sulfur and oxygen, again, molecular. Okay, 2 nonmetals. Which has the highest melting point? Okay, so what you want to do is decide whether or not it's ionic or molecular. So A, right, cesium with chloride. Cesium's a metal. This is a nonmetal, so that one's ionic. These are 2 nonmetals, so that's molecular. Which would have the higher melting point? Right? The ionic compound. Right? Remember, the ionic bond is very strong, and it's hard to get those to separate. It requires high temperatures. Which has the highest boiling point? So again, we're looking for the ionic compound. Okay. Carbon dioxide, right? 2 nonmetals, that's molecular. Calcium and fluorine, metal, nonmetal, this is the higher boiling point. Which has the highest density? So again, the ionic compound has the higher density. Potassium's a metal, oxygen's a nonmetal, that one's ionic, nonmetal, that one's molecular. So choose the ionic compound.